241. Okay. So last time we talked about caller type, right? And object kind. I noticed that you were a little bit tired toward the end, most of us. So let me kind of give you a recap of what happened on the last page, okay? And then we move on, okay? So what happened on the last page was this. So let's look at the main again. And the rules that you want to remember here is this. 1, 2, and 3, and 4, right? We have 4 example. First one here, second one here, and the fourth one here. The rules that we want to remember is this, right? When it's static linkage means no virtual, right? So when it's static linkage, we want to use the caller type, right? We want to use a caller type. When it's dynamic linkage, we want to use the object kind. We want to use the object kind. So for the first one, right? For the first one, we notice that both, right, the caller, right, the owner and the objects, right, are of type egg. So we can see that right away. We're going to pull out the implementation from the egg class. Are we all good? Even though in this case, we have raw only as static and we have, listen only as dynamic, right? However, we are only dealing with one class. So dynamic is here on line number 204. But we are dealing with only one class egg. So there's nothing happen. The most important one here, right, after we warm up and set up is on number 2. So number 2, what we got here is that we got egg, owner, right? Egg caller. And then the object is of type chicken. So now if the caller, right, is calling raw only, from the egg class, we know that raw only is a static linkage. And listen only is a dynamic linkage, right? So now, because there's 2 different classes here, so that's when we have multiple implementation. Multiple implementation mean what? Means multiple form. That's why it is poly, right? Multiple means poly. Poly means multiple. So polymorphism means multiple form. Multiple form here means multiple implementation for the same, function through the inheritance. And that's what, the polymorphism is a product of inheritance. So in this case here, when we have the dynamic, right, on line number 204 of listen only, we said that, well, dynamics mean listen only now is a polymorphic base. That's mean you can look for, right? You can look for the implementation from a child class, right? When there is, dynamic linkage. So in this case here on line number 231, we have, the caller, right? Egg2 listen only. However, because it's a dynamic linkage, so we want to look at the object's kind. The object kind is the chicken kind. And in the chicken kind, listen only is on line number 216. On line number 216 is say, the implementation say that it's chicken, I crow, and, I'm a rooster. So that's why for number 2, right, we have the caller type giving us the first implementation from the egg class. But for the, object kind, we have the implementation was pull out from the children class. Okay? So this the rule that you want to stick with in order to understand and to know which implementation you're going to use, right, in the polymorphism. On line number 233, right, the problem here is that make sure we always remember the test that we learned from 220, the ESER test. We draw, the ESER test, it looks like inheritance, right? But we are testing the product of inheritance, which is polymorphism. So on the right side, we have an egg. And on the left side, we have a chicken, right? So the question here is that every egg going to create a chicken? No, right? Egg can be, a turtle can make a turtle, can make a dinosaur. can make an ostrich, anything. So that test is return false, right? So we're gonna continue to review that test on the next page. For the last one is easy because in this case we are using the child class. So both the caller and the object are being chicken. That means those are the most sophisticated classes. They extend the base class. So of course, we know that the implementation when egg4 calling is going to be all come from chicken. That's it. Okay. It may be difficult first, but after you go through this example here, that's a review for you all the way from 210 to 2340. Okay. All right. So that was the review of last class. So next one, when you go online, right? It's very easy to Google it and start seeing, if you Google virtual, right? Versus virtual, pure virtual, there will be conversation online saying you cannot have an implementation for a pure virtual function, and pure virtual in C++ mean abstract in Java, right? And amazingly, there are actually articles online just to argue this point. So when I read those articles, I was like, this is computer science. Why don't they just put that in code, right? And can see an example for themselves. Why they need to argue this? So that's what convenience about our major, everybody. So I do this. I give you this example so that you have a final answer to all those unnecessary argument online. Online number 247 to 250, right? We have the animal class, and the animal class has a pure virtual function. That means it's an abstract function, and one abstract function is enough to make the class abstract. On line number 252 to line number 259, right, we have the same animal class, but in this case, you see that I put an implementation, a body for the pure virtual, function. I even give, a data field. It works. It works just fine, right? So you don't need, you can save your 7 minutes reading that article online, and we write the, program here. It works, no problem at all. And then we have the chicken class. And the chicken class is, inheriting the animal class publicly. The mouse class is inheriting the animal class publicly as well. All right. So to understand all of this better, I give you 5 experiments. The first, the second, and the third all fail, right? And then the fourth and the fifth, work. Let's spend about 5 seconds, and then we're gonna share with our class, our analysis, our understanding why 1, 2, and 3, do not work, and 4 and 5 work. Okay, about 5 seconds. Okay, why the first one doesn't work, everybody? Why the first one doesn't work? $284. Why 284 doesn't work? That's right. Because animal is an abstract class, right? It's an abstract class, so we cannot, Joel is very good here. It's an abstract class, so we cannot create an instance of an abstract class. Okay? Are we all good? Thank you, Joel. On line number 286, why doesn't it work? 286. Why doesn't it work? 286. 286, why doesn't it work? Why 86 doesn't work? This is where people argue a lot online, right? This is where people argue a lot, and we should have the answer. Why doesn't it work, everybody? Two 286. Why doesn't it work? That's right. It's the same reasons, right? Whether it's implemented or not, it is still an abstract function, right? It's still pure virtual, and it still makes the class abstract. And if it's abstract, you still cannot have an instance of that class. Very, very good. Are we all good here? We should not be distracted by the fact that the function has an implementation, a body, a definition, right? Virtual, pure virtual, right? Make it abstract. And one abstract function makes the whole class abstract. And abstract means it cannot have, an instant, an object. Very good. So 288, why doesn't it work? 288, why doesn't it work? 288, why doesn't it work? If it were not pure virtual, then we can go back to the last example. Of course, we can create an object, right? So in the last example, there are argument online that if it's virtual, it's abstract. Okay, and we clarify that already. Virtual doesn't mean abstract, right? It has to be virtual pure virtual. And then the next question was whether pure virtual can have a implementation or not. That's what we're answering right now. Does it make sense, Joel? Right? So we answer and we clarify all the confusion that people talk about online. So when you go to interviews, you are well equipped. Okay. Kevin said chicken and mouse uninherited classes or same class. Very good, right? So 288, we basically just draw the test again, right to left, right? Is that every mouse is a chicken? No, right? That's going to be a little bit weird if every mouse is a chicken, right? But every mouse is an animal, every chicken is an animal. That is totally fine. That's why 4 and 5 works, right? Every chicken is an animal, every mouse is an animal. However, not every mouse, and I don't know which mouse is a chicken. That's why it doesn't work. Are we all good here? Right? All right. So that's it. That's a quick, review, and it's really make it clear for you. Everything you see online, everybody, even people, agree online during their discussion, they may agree on a different version of C++. Always have a habit of, clarifying. Write a quick program, right? Open the IDE 5 minutes, create a program, and verify the statement right away. So for the next one, I have another interesting situation for you, right? On line number 308, we have a person class. Sorry, 308 to 326. And this person class has constructor, getter, an additional function. The constructor has how many data fields, everybody? How many data fields in there? Have 2 of them, right? We have social security number and we have name. Everybody's good? And then we have a student class that, inherit the person publicly. So 228 to 345, right? Same structure. And on line number 244, we say a data field GPA. So how many data fields a student has, everybody? How many data fields a student has? How many data fields does the student have? Three of them, right? Very good, right? So student have social security number, name, and GPA. Are we all good? So now we create a person, and the person is Social Security 1 to 9 and Mickey. And we create a student, Social Security 9 to 1, Minnie, and has a GPA, right? And then we double check the information. We said, well, the person has the right information and the student has the right information. So on line number 359, we do this, right? What's going on here? On line number 359, who understands the syntax here, the code here? What are we doing? For line number 359, what are we doing? We are calling the copy assignment operator, right? We learn in Big Five, right? Everybody's good here, right? So this is what we learned only, 2 packages away. But there's a problem here because on the left side, we have a person object, right? A person type. And on the right side, we have a student type, right? We know that C++ always tries. But, is it always accurate or not? We don't know. That's where the programmer needs to understand. This situation happens a lot. And there's no error coming out. And, programmer is sitting there saying, well, I lost information and I don't know where it happened, right? So what's happening here is this. We have a person with, Social Security number and name. Social Security number and name, right? Social Security and name. And on the right side, we have student with Social Security and name, right? And GPA. So now we are doing an assignment from the right to the left, right? What C++ does is C++ gonna slice the object and just ignore, the bottom part of it. Only copy the top part, the blue part, over. So the person on the left side, right? We thought that the person would have GPA because, every student is a person. However, the person does not have GPA, okay? And the information is lost. So we call this the slicing problem, everybody. Anyone here that watch UFC and heard of Kimbo Slice, right? If you want to remember this scenario here, right? Just think about Kimbo Slice here. So slicing problem, right? And when we print out the information, we see the information here, right? The person now has Social Security number, right? And has the name, but there's no GPA. On line number 363, why doesn't it work, everybody? Why is the opposite? If we say person equal to student, then it doesn't work. Why doesn't it work here? So there's a slicing, right? So it's a slicing on the top on line number 359. Why isn't there a slicing on line number 363? You can't do inheritance the other way. That's right, Kevin. But what is the other way to put it? Always stick with the basics, right? Not every person is a student. That's it. Are we all good? Never forget our basic tests, right? When we write code, okay? When we write code, never forget the basic test. All right. So I'm walking you through, special situations here, right? So let me know if you have any questions. But we tend to go faster through those examples, not because we are going fast, just because they are special situations. If you have good foundation, then it's very quick to recognize, all those special situations. Yeah. All right. So next thing, let's get to multiple inheritance. Right. Another thing that we can do in C++, but we can do in can't do in Java, but we can do in C++. Right. So let me give you the map first. Let me give you the map, a diagram of what's going on here. So we have a student class, everybody. And then we extend that student class to CS student, and then we extend to CS student 210, CS student 220, and CS student 340, right? So all of them are CS student, right? 210, 220 and 340. And then what's important here is that 340 is upper division, so you are actually a programmer already, right? You can sign up with some freelance company and start making money already. So here we go. We got a multiple inheritance relationship. In Java, can we do multiple implementation, everybody? Can we do that in Java? Multiple implementation? Yes, right? In Java, we can't do multiple inheritance, but we can do multiple implementation of interfaces, right? Because the idea here is this: if we have a class, right, and class have data fields, right, and a set of behavior, you can always add more behavior to it. Now we all good. That's why in Java, they have the multiple inheritance. You have a person who can inherit, who can implement, multiple interfaces, just like picking up, different sets of skills. But the problem here that we are looking at here is this: two different classes, right? That means they have two sets of data fields, and they have two sets of behavior. So now, if you need to merge them into one, right? How many problems we're going to have to deal with? That's the difference between, multiple implementation and multiple inheritance. So now let's explore this together. We're going to start out on the top. This is a very simple example. Another simple example. I try to keep every example very simple, easy to relate. We talk about 210, 220, and 340 here, but we are covering, almost all of the topics that we've been learning so far. In here, you're going to see classes, you're going to see function, you're going to see explicit constructor, you're going to see destructor, you're going to see copy constructor, you're going to see virtual, right? You're going to see private, public, and protected inheritance, right? And you're going to see, inheritance polymorphism, and you see multiple inheritance as well. A lot more than, more than just a simple class, right? So now, if we start with the main, it's on line number 495, right? To line number 520. And the output is on line number 524 to line number 550. What you want to do is that you can either read it from top to bottom or bottom to top. So from line number 374 is a student class. To line number 403, right? Oh no, yes, to line number actually 408. Okay, that's the end. Let me use my ruler here. And then we have the CS student class, right? And then we have the CS student class all the way until the end of that page. And then we have 210 class, right? And then we have 210 class. After 210 class, we have 220 class. After 220 class, we have programmer class. After programmer class, we have CSC 340 class. Each class is very short, right? Because I want to keep focusing on the main point. So let's take a quick look at all the classes and try to explain the output, okay? And in 10 or 15 seconds, we're going to discuss. All right, let's discuss here. See how much we got, right? So now look at the main, right? It's very well organized here. We have one portion where we test, 220 student. Another portion we test 220, and the other one is 340. So let's start with the easiest one first, right? On the top, we create a 210 student, and then we see out a bunch of information. And then same format, we create a 220 student, we print out a bunch of information. And then we create 340, and we print out a bunch of information. The student on 210 is a Mickey, right? So now we start with Mickey being a 210 student. That the output is on line number 225 to 530. In this output, we see the two portion here. Number one, all the constructor call. And then number two is the, 3 lines of output. We notice that in order to create one object in C++ here, right? All the parent classes or constructor will call in order to create this object, right? So we have the parent call, and then the next one call, and then the child. Like it's like building the foundation, and then just keep adding more and more to it, right? So student would contribute to this part of the object, and then CS student contribute to this part, and then CS, the last one, contribute to this part. And that's how, we create the object in this case, right? Everybody see what's going on here, right? So we have an object in this case. We have this object here. So now, on line number 520, right? We see a problem. We see that a simple thing that we do all the way in Java, and it's always right? Name a student Mickey, how difficult it is. And here, C++, we cannot do it. The student's name turned out to be student. So what is going on here? What happened? Why did we lose Mickey? Where did we lose Mickey, everybody? Next time I should change this topic, this student's name to Scooby-Doo. Scooby-Doo, where are you, right? How did we lose Mickey here, everybody? How did we lose Mickey here? Anyone has an idea? Did we see that in the last 10 seconds when we were reading? Did we see that we lose Mickey? Who can explain this problem, everybody? If you are debugging, right, this program, right, this is not a syntax error, right? This is not a runtime error. This is a logical error. Then where would you start to debug this problem? Where would you start? We are creating a student, right? That means we are calling the constructor. So we got to just, look into the constructor. Does it make sense now? That's right, Alfonso. So we are creating, 210 students. And let's look at the 210 constructor. Let's see what is going on with it. So if we look at 210 constructor, how many constructors do we have? Everybody, for 210? 2 of them, right? 1 and 2. And we see that when we say make unique, and we use a make unique command, we pass in Mickey, so we did not use a constructor that takes no argument, right? We did not use this one. So we must have used the one that has, that has one argument, which is this one, on line number 435. 435, what's wrong with it? Why did it not work? We see that we pass in, student name, and student name was, used to initialize student name, right? For the object, right? However, we notice here something is going on here, though. Something is going on here. So we start out with student name being 210, right? And we said, well, I want student to be Mickey, so that was okay. And then what happened is that between line number 435 to 436, right? What happened between those two lines, everybody? As we learned from 210 and 220, what happened between two lines? Or better way to put this question is that what happened, right, silently on the first line in the body of a constructor or a child constructor? How about that? To give you more hints there. The super constructor is called, right? It's quietly called, right? That's in every child, right? Constructor. The super constructor is called. I just explained to you right here. I just explained to you at the bottom here. Are we all good? If we are creating a child, right, we got to have the super constructor call first before we can get to the child. Does it make sense here? So in this case, when we are creating 210, we see that, CS student was called, right? And then student was called in order to build all of this for us. So now we were trying to pass Mickey down in order to have the student named Mickey, right? And somewhere along the way, Mickey was lost. Where did we get lost? Where did Mickey get lost? Right here, between line number 430 and 436. In C++, right? If we want to pass, the name of, or any parameter up to the parent, we have to specify, how it's being passed. And in this case, the only way to pass it is to, unless we use static variable, is to what? To specify which constructor we want to use. And in this case, we don't specify. Because we don't specify, so in the parent constructor, right? In the CS student constructor, the one with no argument was used. And Mickey was not passed up there, right? So that is the reason. So now if we look at 220, let's see if 220 solved that problem. 220 on line number 454. On line number 454. You noticed another use of the initializer list right here. In this case, we say, I'm creating a 220 student, and I'm using the student name as the name for the student, and I want to make sure that, in the body where I call the super constructor, I want to call the one that takes one argument. So there we go. So you want to write out another use of the initializer list in C++ is that you can specify which super constructor you want to use. This is really cool, right? You have more control of, how it works versus Java. Okay, in Java, if you want to call a specific constructor, you have to make that happen in the body explicitly. And over here, you can use a constructor. You can use the initializer. Okay, so that answers the question for us here. So we say that we see that the name student was because we need to specify exactly which constructor from the parent class that we want to use. So now let's continue looking into this example here. We see that when we call say something did not come from 210, but it came from student class. Anybody know why? Why say something came from student class but not CSC 210 class? Anybody know why? So say something, right? So if we look into 210, we see that 210 does not have say something, right? So that means say something might be coming from, CS student. And we do have say something coming from CSC, CS student, right? And in CS student, on line number 427, say something is calling, the say something from the student class. And student class, say something, actually came from line number 405. And before 405, say something was actually a protected function from line number 398. Are we all good? So I'm giving you more syntax in this case, right? So we can work with multiple classes and inheritance and polymorphism at the same time. So there we go. Okay. So now next thing we want to look at, is that when we say hi, right? Say hi came from CS student, did not come from CSC 220. So what's going on with say hi? So say hi from 210, we did not have say hi, right? From CS student, we did have say hi, right? We did have say hi from CS student. And then we have another say hi coming from, student class, online number 389. However, this say hi here is a virtual one. So if we have two virtual, right, from the two parent classes, it's going to use the latest one. Everybody's good now, right? The last one that was implemented. So that is the rule. We can pick up, a bunch of rules here when it comes to inheritance and polymorphism. Say hello. So say hello finally came from 210, right? And say hello came from 210 because in 210 we had say hello. Say hello was a virtual one, but after 210 we don't have anything else. And did we have another say hello up there? Did we have another say hello up there? Yes, we did. On line number 393, we also have say hello, and it is a virtual, right? Okay, and we learned virtual last time. So this is wrapping up all the examples in one for us. Now 220. 220, the same story. We have three constructors, right? And name of the student is Mini in this case, so it works, right? Because 220 did specify that, 220 sent the name of the student up to the parent. However, that's not all, right? That's not all, because 220 on line number 455, specifying that CS student gonna be using the one that has one parameter. However, we have to continue, everybody. We have to go to CS student, and we notice that for CS student, when CS student accept the string, right? CS student continue to specify saying this. For my superclass, for my parent class, I'm also calling the one that accept a string in order to pass, Mini all the way up to the parent class. And because in the parent class, we have two constructor as well. If we call this one, then Mini will be lost. But in this case, we are calling this one as one student, and that student was used to override the value of the current student, of the default student, and the value of default student on line number 401 is a student. That's the name for the student. Okay. All right. So next one, what we see here is that after we constructing the object, we got say something, and say something came from student for the same reason here, right? Because 220 does not have student. CS, that's where we say hi there, is the same reason up here, right? And say hello, 220 does not have say hello. That's why say hello came all the way from student, right? Let's see. 220 did it have say hello? There we go. 220 actually have no function at all. That's why it came from say hello. So now we can go to multiple inheritance, right? Multiple inheritance. We notice this, everybody. When we call the constructor, 4 constructors was called in order to create 340 student, right? You see how much it takes in order to be a 430 student, right? But the question we have here is this. On line number 543 to 544, why was the programmer class called first before 340? If they are both, equal parents of 340. Oh, I'm sorry. I mean, why the CS student was called first before programmer? If both CS student and programmer are equal parents of CSC 340. Anybody can explain why here? Those are the details that we want to pay attention to, right? What is going on here? Anybody can explain why? What line number, Kevin? What line number? Is there any line number here? 410. Let's look line number 410. 410. 410. 410. 410. No, 410 doesn't. Pretty close, but no, not 410. Not 462. Not 462. Not 462. For those two blocks of code, C++ does not give a priority, for which one first, for those two blocks of code. But somewhere else, right, that it matter. Somewhere else. You're on the right path though, right direction. Somewhere else that say 477, that's right. Right. Oh, by the way, Boeing, discontinued the 747. 477 remind me of that number. So in this case here, we have CSC 340, right? On line number 477, there's an initializer list, right? And it specifies that CS student goes before programmer. Everyone's good here, right? So there got to be an order when you create an object, because it is like a stack. So you cannot say, well, I have it create at the same time. At the same time, then you have left or right. So there got to be an order. So that's what that's what explained right here. So if you go right away to the destructor, right? I want to connect the dots here for you. If you go right away to the constructor, to the destructor, you see this. 210 got to be destroyed last, right? Because 210 was created first. And then 220, and then 340, right? So the order is reversed here. If we call CS student first to create, right? Then CS student got to be after programmer when we destroy. Everybody see the connection here, right? When we create, if we call the CS student first and then programmer, when we destroy, we got to programmer first and then CS student. Make sure we make that observation, okay? So now the next thing we see here is this. Something came from student, we understand that. Say hi came from CS student, we understand that. Say hello came from student, we understand that. Favorite sport is tic-tac-toe, and favorite language is modern C++, right? I know that Jay doesn't agree with this, but for now, right? So where did those functions come from? Favorite language came from 340, right? And then favorite sport came from programmer. There we go. So now in 220, I spent about 45 minutes dealing with all the collisions that we have when we do multiple implementation. You can get that package from me if we want to, but I want to give you a couple of examples here, okay? If we have a collision, for example, we need to know this in order to understand what people do. But most likely, when you go to a company, they're not going to allow you to do multiple inheritance anyway. But our job is to understand how things happen. So here, if we have multiple data fields from parent 1 and parent 2, right? And then we have, parent child here, right? So what happened is that the child gonna receive all the properties from the two parents. And then the child is going to receive all the behaviors from the two parents. When there's a collision, right? The general rule is this. The easiest way to handle a collision is that, for example, here, if you have data field F1 over here and F1 here that, have the same name, what you do is that you're going to create your own F1. Then this is not overriding. They call that overshadowing, okay? Then it's almost like a local variable in this case. So now if you create your own F1, then the data field F1 going to be the one that you access if you call that field directly. However, if you go up, you say, for example, my child 1, right? And you use the dot operator, and you go up to parent 1, and then you use the, binary scope resolution operator, and you access, F1. Then in that case, you can still access, the other data field. Given here that it is being a public data field. If it's private, then you have to call the setter and getter. And we all know that retail, okay? Same for functions, everybody. For example, if for the behavior, right? If you get one behavior here, that name, action A1, and there's no action A1 on the left side, then it will be inherited here, and action A1 gonna be, your action. But if you have action A1 here and you have action A1 on the right side also, that's when you have to write your own action A1 in order to, overshadow the other two, right? So when we talk about overshadowing, there are a couple of other things that we need to deal with here. When it is static or not static, that's the two different ones. If you have a static function here that has that name, but you have another function here that does not have the same name but is not static, then the instant function, right, gonna have higher priority. Okay, so be very careful between overriding, right, inheritance, and shadowing and overshadowing. Okay, and the same syntax is called, if you want to pull out a static function from a parent, you would say, child 1, and then you go to the parent and you pull out that action 1. Okay, so that is syntax. In Java, right, we just use a dot operator, and you just, name the parent. You don't need to go from the child. And then C++, you want to use a dot operator and then binary scope resolution operator in order to give the path. And that's what we do in assignment 3. All right. Any other questions, everybody? Finally, we are able to read, big program in C++ with, pretty good at pretty good speed here. So if there's no question, I want more interesting cases in package number 13 for you. So let's open package number 13. So this is a very interesting situation, right? I'm going to wait until you open, and I'm going to just mention the names as you are opening it. Are you ready, everybody? We are looking into the cyclic reference problem, okay? And then something new in C++, and we only have in C++, is a friend access, right? Friends, this is something we don't have in Java. It's friend access to classes. This is new. This is modern C++. But before we get there, let's look at the cyclic reference problem, right? So now, in order to demonstrate the cyclic reference problem, I'm going to use chicken and egg again. And in this case, there's no assumption whether chicken or egg came first, okay? So the last example, when we learn virtual, right, polymorphism, we assume that the egg came before the chicken. Here, there's no order. So now let's see what happens when there's no order, okay? So now, let me see here. On the first one, we have the chicken class from line number 5 to line number 20. Right? In order to, in the chicken class, we have the chicken constructor, we have the chicken destructor, we have a chicken getter, right? That returning an egg. Because on line number 19, we see that, we are having an egg share owner. Are we all good? And then on line number 14, we have a setter, right, to set the egg, because the chicken is owning an egg. That's the whole story here. So the chicken here is owning an egg, right? And then we have egg that own a chicken. No, so we're gonna be good at both computer science and philosophy here, coming out of this class, right? So we have egg owning chicken on line number 36. Egg owning a chicken. Egg owning a chicken. Near my neighborhood, everybody, there's a bar, right, that I really like. Near West Portal, yeah. The name of the bar is Philosophers Club. Because you go in there, right, you drink 1 or 2 beers and everybody become philosophers, They keep talking. That's a great name for a bar. And then, oh, you been there? You been there? Okay. So on line number 24, right, we have a constructor, and then we have a destructor, and then we have a chicken getter, and we have a chicken setter, and of course we own a chicken. All right. So are we clear about the story we have, everybody? We have a chicken class that own an egg, and then we have an egg class that own a chicken. Right. So we have the cycle there. So now in the main, let's do this experiment here. In the main, we create a chicken, owning a chicken, and then we create an egg, owning an egg. Are we all good now? And then we output the information about the chicken and the egg. So at first, right, we say this. We have a chicken at 0 BC owning, no egg yet. And then we have an egg at 27C owning no chicken yet. And then now we're going to create the cyclic reference. So in order to create the cyclic reference, we say this. Chicken, I'm going to set the chicken to own the egg. And I'm going to set the egg to own the chicken. And then after that, we output the information to see what we get, right? So now we see that the chicken is owning the egg, right? And the egg is owning the chicken. There we go. And we don't know who owns first, right? And then what did we do? On line number 57, we say chicken.reset, right? When we say chicken.reset, that means it's supposed to destroy the egg, right? And reset chicken to be owning 000. And then we say egg reset, that means it's supposed to delete the chicken and set the egg to be equal to 00. And at least we got to expect 2 destructor call, right? 2 destructor call to happen here. So we expect 2 destructor call before the end of the program, right? Before line number 60. Okay. So now what happened here is this. When we call the reset here, we did not see any destructor call fail. At the end of the program, we are using smart pointers, right? We expect that, well, if not before, then after the end of the program, we expect that, we should have destructor call, and destructor call should happen right here. But after the end of the program, we did not see any destructor call either. Who can explain this problem here? What's happening? Why we could not make any, destructor call, and, smart pointer did not help us manage memory in this situation? Nothing call, right? So this is one of the situations when we say, smart pointer, cannot do it all for you. You still have to understand what's going on and set things up properly. So one quick sentence here. Why did it not work, everybody? Why did it not work? Oh, who sees the problem here? Why did not smart pointers work for us? Anyone? Why did not smart pointers work for us? Are we still here? Who's still here? Who's still here? Oh, I'm disconnected. Oh, okay. Thank you, Joel. Why did not it work, everybody? Why did not it work? How come we could not reset, and how come we could not? Oh yeah, it is cyclic referencing, right? But how do we explain cyclic referencing here? How do we explain that? We have a chicken, right? And we have an egg. And chicken is a owner of an egg, right? Of an egg. And the egg is an owner of the chicken. So now what happened? When we say, I want to destroy the egg, right? What does the egg say? What does the egg say? When the chicken say chicken want to destroy egg, right? What happened, everybody? When chicken is what? Chicken is a share pointer, right? Chicken is a share pointer, right? And eggs is a share pointer as well. So if you want to destroy egg, right? If you want to destroy egg, what is the condition to destroy egg, everybody? What is a condition to destroy egg? What did we learn about the control block? If we want to destroy the object, right? The number of share has to become to 0, right? Are we all good, right? So egg say, well, you can get rid of me if you get rid of chicken first. And then we go to chicken, we said, I want to destroy chicken, right? Chicken said what? If you want to get rid of me, I'm being a share pointer, you have to get rid of an egg first. And we are stuck right there, right? And we are stuck. And after the end of the program, the same situation. That's why no destructor code. Are we all clear about this, everybody? Are we all clear about the problem here? Right? Are we clear here? Before we solve the problem, we need to understand what the problem is, right? Before we can share the problem, before we can solve the problem. Are we all good? Are we all good? Can I move on to the solution? Can I move on to the solution? Hello? Okay, I go over it one more time, okay? Yeah. Let me erase it for you. All right. Let me start with something simple first. Not the full diagram, okay? Just the half of the diagram. So we have a chicken, right, that is owning an egg. So now, if a chicken owning an egg and the chicken is being a share pointer, right? Before we said, well, if we have an object being owned by share pointers, are we all good? The condition in the control block in order to delete an object is that the number of the owner has to be 0 in order to delete the object, right? We don't need to talk about control block here. In order to delete the control block, we need both 2 0, right? So we just talk about the object in this case. So we say this, in order to delete the egg, right? In order to delete the egg, what do we need to do? In order to delete the egg, right? So we say, I'm trying to delete egg, right? So egg said, okay, let's get rid of object's egg, right? Let's get rid of object's egg. But I'm being owned by the chicken, right? I'm being owned by the chicken. So you have to get rid of the chicken first. Are we all good? And then we say, okay, let me try to get rid of the chicken here. And the chicken said, well, if you want to get rid of me, you have to get rid of the egg first, right? You have to get rid of the eggs first, because the egg is owning me. The number of owner has to become to 0 before you can get rid of the object. So we have a cycle there. Does it make sense now? Every time you try to, get rid of the object said, I'm being owned. That's why you cannot remove. Okay? So owning each other here. Are we all good? Joel's good? Everybody else good here? Everybody see the problem here? Okay. So now let's go to the solution, right? Let's go to the solution. We need to break this cycle. Okay? So with the same exact code, everybody, the same chicken class. The same chicken class. And now we have the egg class, 86 to 101. The way to break this is this. We just break one connection. On line number 110. This is a fix. We make, one of the connection, instead of ownership, we replace with no ownership. We replace with, only monitoring, right? Only observing. So that means we only have weak pointer. Everybody's good now? So we are saying that, now we have the weak pointer chicken. Okay? And the chicken here gonna observe the egg, but does not own the egg. That's it. So we break the cycle here. Chicken only observing the egg. So let's represent that by a dotted line. So only observing the egg, but not destroying the egg. So now, if we want to get rid of the egg, right? The egg will not have the problem of, well, you got to get rid of my owner first. Everybody's good, right? So half of the circle, we solve it. So now the left side can get destroyed, and the right side can get destroyed too. And here we go. So let's look at the setup here, right? We do the same exact thing. We have chicken, we have egg, and then we establish the connection, right? So now we say the chicken object, right, is owning the egg, right? So the chicken object is owning the egg at A4, right? That's two different addresses. And then we have the egg object, right? The egg object, the egg is observing the chicken. That's our setup here. We have the egg observing the chicken, right? And then it is no ownership. That's why there's no address here. But using only expire to check whether the chicken is still there or not. So now, after the end of the, we get set, and then we did not do anything. We do not need to reset at all. And at the end of the program, right, we see that the destructor still wakes up. The destructor still wakes up, right, and destroy all the objects for us. Everybody's good here? So this is how you solve the problem, when you have a cyclic references among, multiple smart pointer objects. Everyone's good? Okay. All right. So we are just going through special situation here. Any question for me here? That's right. We break, we have to break a tie, right? We will break the tie and we have to replace, one ownership by observation. Okay, one ownership. What we see from this, everybody, the more you program in smart pointers, right? You're gonna see that most of the time you're gonna start out with unique pointer. You rarely use share pointer, and weak pointer is very powerful. Okay, so the more you program in C++, you're gonna see, well, what I just shared with you is very true. Okay, that's what from textbook and from my own experience as well. We always start out programming with unique pointer. Don't start out with share pointer. It's very heavy, all right, very expensive. Okay, always start out with unique. If we need to convert to share, we convert. And always take advantage of weak pointer. Very nice. Okay, very, very nice. So the next thing I want to give you here is the friend access. All right. The friend access is something that we only see in C++. So what do we mean by friend access? So now let me give you a bunch of classes and I explain to you how many kind of friendship that we can have. Okay. How many kinds of friendship that we can have. So here we go. We have 210 class on line number 136. We have a 220 class on line number 148. We have a 340 class on line number 161. And I want to make sure that I always get back to inheritance for you. So on line number 175, we have 340 child class inheriting, 340 class. And what was it more than that? I also use, some global variable, right, outside, to see how it works for you. So I create a bunch of global variable function outside for you. And here we also have the implementations of, static classes outside here as well. Okay. And then we have the main on line number 213, and then we end on line number 234, and the output over that at the bottom for you to observe. But it's pretty straightforward after you understand my explanation on top here, right? So the first thing we want to do is this. We're going to look for all the friend keyword, right? On line number 155, right? We see this. We give a friend keyword here, and we say friend void 210, right? And we give a path, and we say this is the name of the function. Okay. So what we are doing here, everybody? What are we doing with this one? What are we doing on line number 115 here? We are saying this. We are giving this function here in the 210 class the right to access all the private and protected members of 220. Okay. So now this function here, right? This function here on line number 139 now has access to all the private and property members of 220. However, 220 does not have any access to, the member of 210, private and protected. Okay, so that is the first meaning and the first kind of friend. Did everybody take note? Is that clear here? Let me repeat, right? Let me repeat the first one another time to make you understand better. When you say friend, you are granting access. Everybody's good now, right? And you are granting access to whom? You are granting to access to a function in 220. And the name of the function is right here. I say, CSC 210 accessing 220 to make it easy for you to understand. And then we say accessing what? We can access private and protected member of 220. All right? So that's the first kind of relationship, friend relationship that we have. On line number 167, we said this. We are granting the access, right, to the protected and private member, right, of 340 to this function. Are we all good? And then same as line number 168, we are giving the access to this another function to the protected and private member. On line number 169, we can have a friend access from one class to another class. So now, what's important to remember about this? If we give, 220 the right to access 340 on line number 169, it happens only one way. Okay? Doesn't mean that 340 gonna have access to 220. Everybody's good here? So now we see here there's an inheritance relationship here, right? Inheritance relationship here. So if we, where did I give the inheritance for you? Here we go. So on line number 181, right? 181. We see that this function here, okay, have access to the parent class. But we have to remember that a friend of the parent is not a friend of the child, okay? So this function here does not have access to the child class. And then same, a friend of the child, right, is not a friend of the parent. The friend of the child does not have access to the friend of the parent. Are we all good? So the relationship here only happen one way, okay? Is there any other point that I can give you here? The demonstration on the right side, right? Basically just output exactly the same, whatever I was just saying here. So you can see that the whole demonstration here, it says that when you give a global one, right, it can give you access to 340. This one gave access to 340. This one access to the child of 340. 220 to 340. You just have to go back to all those lines. So let me ask you an important question here, right? And this question gonna help you put everything together, okay, for this example, for the friend relationship. So now, when we say, if we do inheritance, right, from a child to a parent, most of the time we think that the child is inheriting everything from the parent. But now let's take a step back, right, and review from 210 to 340, okay? First question, is that true that you inherit everything from the parent, everybody? Is that true? Do you inherit everything from the parent? Do you inherit literally everything from the parent? Yes or no? Anybody say yes, anybody say no? Who say yes, who say no?
No.
No, right? All right. So not everything. That's good. That's the first. If you go to an interview, they say, is that true that a child inherits everything from the parent? No. So now in the no, that means you do inherit, but except what? Let's list that. Let's make sure we have this list here. So how many things you want to list out? You inherit everything from the parent, but what? Who gonna give us all those that we don't inherit? We do not inherit private member. That's very good. We do not inherit. Let me put in the red text so it gives you better impression here. So we do not inherit private, right? But can we access and modify the private members? Can we? Can we? There's a difference between inheriting and accessing and modifying, right? If the setter and the getter are public, then we can still access and still can change, right? Are we all good here? So in the interview, they're gonna put the questions in different ways. So make sure that we know the difference of the things that they are asking. Okay. What is the second element that we don't inherit? What is the second element that we don't inherit? What is the second one? We just learned, right? Friends, right? The friend of the parent is not a friend of the child. And the friend of the child is obviously is not the friend of a parent. Are we all good here? We do not inherit friends, right? What else? We don't inherit, everybody. What else? What else we don't inherit? Do we inherit constructors? We don't, right? We don't inherit constructor. The constructor, a lot of people argue about this point, but we just learned already. It's just because the child constructor always, right? If we don't explicitly write the command, it will silently call the parent constructor. All right, that's how inheritance, it is. That's how inheritance is constructed, but it's not because of the child inheriting the parent constructor. The problem with a child inheriting the parent constructor is what? Every time, right, we create a chicken, we're gonna create some other animal, right? Are we all good? If we have both two constructors in there, okay? So the last thing that we don't inherit from parent is what, everybody? The last thing that child class doesn't inherit from the parent class is what? Can someone think of it? We talk about private, members, right? Including everything, data fields and behavior, friends, constructor. What else? What else, everybody? We don't inherit. We don't inherit. Oh, that's a good one. Constructor goes with destructor. That's right. That's right. But usually they count those two as one, right? Because they go together. There's another one is assignment operator, everybody. Okay? Assignment operator. That's what we don't inherit. Because each class has the assignment operator overloaded differently, right? So those are the four things, and depends if you want to call destructor as another thing, and that is not inherited. Everybody's good now. Some of us may say, how about the copy constructor, right? And the move constructor, same here. It's the same. So those big five, right? Except the assignment operator is on the outside, but the move constructor and the copy constructor is also listed as the constructor, and that determines how we write the destructor as well. Are we all good? All right, so those are two more special situations that I'm going to give you. I want to make next week, right, as light as possible for us so we can focus on the review. So now let's move to package number 15 and learn the lambda expression, okay? Because lambda expression going to be a standard when you graduate, right? And I don't want to leave that as the last topic. I want to have enough time for you to digest the topic. So let's go to lambda expression right now. And if we have time for sorting, we can learn more sorting next week. And sorting is fun to learn, so let's leave that easy task later, okay? Let's learn lambda expression. Lambda expression, a package that package number 15. Thank you, Isaac. Package number 15. This package, as usual, right? I give you information from very foundation to really, really advanced. I will try to cover as much advanced topic as possible for you, right? But on the exam, we only cover the basics of lambda expression, okay? That means we only, in the exam, we're going to cover only up to, here. We're going to cover only up to 521, right? So let me mark here. On the exam for lambda, for the exam package number 15, we're going to cover over, what did I say? Is that 512 or what? 515? Package number 12. Up to Up to what line number? I just said. I forgot. 521. 521. Thank you, Kevin. Wow. Kevin has good memory, huh? 521. Do we know that the CEO of Google, if you read a phone number, to him, right, 9 digits, he can remember right away. He has photographic memory. Amazing. Did you know that about the Google CEO? So you know one criteria if you want to be CEO of Google now, yeah? Okay, lambda expression. All right, let's talk about lambda expression. So what we got here is everybody. This is the last area in the 5 area of memory, and we're going to investigate, very closely what's happening. So let's talk about function pointers first. Lambda expression is a very good topic, but many people would give up because it's very complicated. If you jump right into that topic, it's very difficult to understand. So I'm going to take, further a couple of steps back, and try to start from what we understand. And then I'm going to lead you to that topic, okay? So now we have to start with function pointers first. So now on line number 11, right? On line number 11, we see the macro again, right? On line number 1, and this macro saying what? Whenever we call hello, right? Hello gonna see out the string that we pass to, that hello function, right? On line number 12, we have this. We have function hello, and it's basically just print out a string S, right? On line number 17, we say hello area 5. It takes no parameter. On line number 21, we said hello 340, and it takes, an integer, right? So now those are pretty simple, but then, and they are there for a reason. When we get to the code, I will explain to you why I use a very basic example to explain something else to you. On line number 25, we say this: if you pass to me an entry, right? If you pass to me an entry, I'm going to print out that entry. Wow, how simple. But now on line number 29, right? What's going on here? Who can understand line number 29? This is how, people get so confused in lambda expression. So now let me take a step back, right? Let me tell you this. We have the map for C++ memory. It looks like this. And here we go. We have area 1, 2, area 3, area 4, area 5. We have unallocated memory area 1, 2, 3, 4, and 5. So when we have a function, for example, the function on line number 13, right? We store the code of the function in area 13. And we say this, and we say function hello. So my question for you is this: function hello, is that a reference? Is that a pointer? Is that a label? What is it? Right? So from 210, right, we give a name to a method. We give a name to a function in 340. Did we ever ask the question saying, is it a function hello? Is a pointer a reference, or just a simple label that has no connection? What is it? We know for sure that, when we use that name, we can call the function, right? We can call the function. We know that if we have a function that with that name, we can't change it, right, to be, referencing, pointing, or connecting to a different function. Function hello forever will be function hello. So what function hello really is this. it is a pointer, okay? It is a pointer and it behaves like a reference. So that's what's going on here. It is a pointer that is behaved like a reference. It is constructed almost like a reference as well. Because, we can have hello, right, coming from different area, for example, from the main. And it is a pointer to that function code, right? However, if we print out the address of that pointer, it's going to say the address is in area 5. That's why, it's construct like a reference. And also, we cannot change it to point to something else. We cannot know it either. Okay? So now, on line number 29, right? What's difficult on line number 29 here is that we don't know what is happening in this parameter list, right? We don't know what's happening in there. So now let me take you step by step, right? And to the point when we understand what's happening. So first of all, on line number 37, if we say hello Mickey and hello Minnie, right? We're going to output hello Mickey and hello Minnie because what macro does is just replace hello with this line of code. And then it takes the S parameter and just put that in that code right there. So it print on line number 42 to 43. And there is no function, there's no function pointer, there's nothing happening here. Okay, so that's the basics that we want to cover. In test number 2, right? In test number 2, if we call function hello, it's gonna output hello there because the default value of the parameter, if there's nothing passed to it, is there, right? Did we see that here? There, right here. So now, if we pass in Mickey and Minnie Mouse, and we call hello Mickey and Minnie, right? We are seeing that it's printing out hello Minnie and Mickey. One special observation that we need to make here is this, right? On line number 46, usually, if it is a pointer, and if we want to call the content, right, or something that the pointer is pointing to, we are using a dereference. In this case, it is a pointer, but we are using it and treating it half as a reference. So there's no dereference, right? There's no dereference. However, it is a what? It is a function pointer. In order to invoke a function, right, we have to use the opening and closing parentheses. And that's how we invoke, a function through a pointer. All right. This is an important syntax, and we never, really explained before. So now, if we move down to the test number 3, that's when it got interesting here. In test number 3, what we did is that we're saying on line number 54, right? We say this: I want to create another pointer to the function to see how it works, right? And I don't know how to write, the syntax to create a function pointer. So I'm going to just use auto. Okay, when I don't know, I just, try to get the help from C++. And I said this: I want to create this function here, this function pointer, and this function pointer gonna point to the function, whose name is function hello area 5, right? Hello area 5 is on line number 17. So now it says hello area 5, right? So did it work? It did, right? Because when I output this, pointer with the parenthesis call, it output hello area 5. So what's interesting is this. Number 1, if we print out the address of function hello area 5, it's gonna give us address, 988, right? And then if we print out the function of function hello area 5, right? Not the pointer, but the original function, we're gonna have the address of 7E9. So totally, those are two different pointers. Okay, so we just pick up one things, after one thing at a time, and we're going to understand it better and better. On line number 5 here again, we see that we use a parenthesis in order to invoke, and make a function call through a function pointer. So now let's go to line number 64. If we don't want to depend on the keyword auto, right? There's a way to create a function pointer, and we call that the actual type, right? You're going to have this on the exam, so you want to make sure you understand this. And I want to tell you right now that when it comes to lambda expression, right? Whenever there's a problem and any difficulty that you have, you want to get back to actual type. The actual type going to help you solve all the problem in, function pointer. Okay, you want to stick with that. So what does it mean by actual type here? The goal of this command is what? We want to create a function to function hello area 5, right? So now if we look at function hello area 5, function hello area 5 is a void function, and it takes no parameter. Are we all good? It's a void function that takes no parameter. So the actual type of that function that we are trying to point to is a void function that takes no parameter, right? So in order to express that, right, we have to map the exact, structure right here. So we are saying this. On the left side, we say this. I'm creating a pointer to a function, and that function is a void function, right? And that function takes no parameter. Are we all good? The name of the pointer that I'm going to use is function hello area 5, 2. And it is a pointer. Everybody see how the actual type is working here? And this is the simplest, syntax. So I want to make sure you get this before we move on to the next, right? And I make it easy for you by always outputting all the information. On line number 66, if we want to try to test and to see if that function pointer is working, we make the same function call. Make sure that we have the opening and closing parentheses. If we print out the addresses, right, what we notice here is this. The function that we are pointing to is still at the same address, right? And then the function pointer that we just create a new one is as a new address. So things are working, right? So now there's another way to create a function pointer is on line number 75. And we call that function object. In order to use, function object, we have to include here on line number 7. We need to create, we have to include functional, right? So what we are doing now here is that we are trying to create a function object that store a callable object inside it, right? That's how function object works. So here we go. We said function phi is a void function that takes no parameter, right? So what on the left side we said this, I'm going to create a function object, right? So this is a syntax. I'm going to create a function object, same as the syntax for the vector, right? And the type of the function is that it is a void function and it takes no parameter. So I can put a void in that, parameter list as well. And here we go. I call the function object as give it a name and give it a function to, to point to. And we're going to invoke the function the same way. And here we go. We print out, it works the same way. And the original function is still in area 5. And we just create another function. Two other ways to do this, right? First of all, is the traditional way is the type def, right? And the other one is using. So in the new C++, we do not use type def anymore, right? And we use using, okay? But I'm going to explain both to you, and you will see that what's the difference between the two here, and especially how it different from the other. So when it comes to type def and using from the name here, right? Type def means what? We are defining a type so that we can reuse that type. In the previous approaches, right, we just create only one function pointer, and then that's it. If we create another one, we have to follow the same step. But over here, if we create a type, and then we can reuse that type. So on line number 87, right, we say, I'm going to create a pointer type, okay? And this pointer type is going to point to any function that is, being a void function and that accepts, no parameter at all. That's the type that I'm using. And I'm going to name that type, right? Function hello area 5, type def. What doesn't really make sense here is that, even when we are naming the type, we still have to put the star here, right? That's why C++ is trying to get rid of that part here. So now it takes two steps, right? Number one, we create the type, and number two, on line number 88, now we use that type. We use that type, and we said, well, I have a general type here that is ready, to point to a function that return nothing and accept and takes nothing. So now they say, okay, if you name the new variable being, function hello area 5 pointer 3, then you got to give the address of the function in area 5 that you want to refer to. So here we go. In the initializer list, we just have to give the name of that function. Are we all good? And then after the two step, we can, invoke the function, and it output the same way. And for the result, for you to check, the original function still has the same memory address. And here we go. We have a new, function pointer, right? So using is the best. Using is what I like best when it comes to create a function pointer. On line number 99 here is very clean, everybody. On the right side, right? How beautiful it is. You just say it's a void function, and it takes no parameter. That's it. It took, C++ quite a long time in order to come up with, such a clean declaration of a function pointer. And then on the left side, we say using, and then here we go. We have the type right here. We have the type declare. So now having that type, right? Having that type. And now we said, this is great syntax here, right? It says this is a syntax of the pointer. So for this pointer, let's see what's going on. We say, this is the name of the pointer, right? And this is a type of the pointee. That's it. This is a type of the pointee. This is a type of the pointee. It is a function that it is a void one that takes no parameter, right? And I'm going to put a star here to say that I'm creating a pointer. And which pointer am I pointing to? I'm pointing to this function. Okay. So if approach number 7 is easy for you, you want to start with that, and then you can learn the other one as well. And here we go. You make a call to that function through that new function pointer. And then if you print out the information, we see the same here, right? And then we see the new here. Okay, so now we are getting very close to the idea of lambda here, okay? I hope you're all doing okay so far. So the next thing is this. On line number 111, right? 111, we are saying this. Function hello CSC 340. So function hello CSC 340, taking one argument, right? One argument. So now the problem that we start seeing it with this is this. On line number 11, we say, I'm creating a pointer. Function pointer. Hello CSC 340 equal to function hello CSC 340, right? So my question for you is this. What if function hello CSC 340 was overloaded, right? If it was overloaded, and we try to create a function pointer on line number 11, how does this right side here cover, different variation of the overloaded function, right? So that's the question we're going to start asking, and we're going to see the problem with declaring function pointer right here, okay? And then we see that in this case, we are lucky because there was only one definition of function hello CSC 340. That's why on line number 112 to 114, if we pass in a number, right, C++ said, well, I'm going to look for all the overloaded version of that same function, but I found only one. So it was working just fine. So now we're going to solve that problem later, after we understand lambda better. On line number 221, right, we say, on line number 222, we say, I'm going to create a vector. And then on line number 123, we start to, get very close to lambda now. We call a function, and in that function, we are passing in a vector, and then we pass in another function. Did we ever do this, everyone? Did we ever do this? We call a function, we pass in a vector, and then we pass in a function as well. So what is going on here? Okay, so please think about this one, and next time we're going to finish this topic. All right, line number 126. Thank you so much, everybody. I will see you next week. We're going to have the last lecture to finish this topic. We're going to go over sorting a little bit, and then the last class we're going to review for the final exam. The schedule is posted on Island. Thank you. I will see you. Bye, everybody. Thank you so much. Thank you. 127. 127. Thank you. 127.